Okay. Yeah, but I think if we could just start, share a little bit about what it is that you guys are doing, what your role is and everything, and then we can sort of go in there with more specific questions.
Okay. Maybe I can try to share my screen.
Yeah, that'd be great.
Just double checking where to start. So share everything. It's more easy. Okay, so and then okay, can you see my screen?
Yes, we can.
Okay. How do we start? Okay. We have basically two things we do. We have data pre-processing pipelines. They are all Kubeflow. And then we have model training jobs. And then there are two types of model training jobs. One are the foundation model training jobs. And then there are the fine-tuning jobs. And we are not completely there what to use for the training. So we are supposed to do use MCAT. I assume you know what MCAT is. If not, let me know. For the foundation model training, and this is working fine. So it's working nicely. So we have installed the Codeflare stuff and everything in MCAT on OpenShift, and we are using that one for the foundation model training. For the fine tuning, we are supposed to use KKit, but we still use MMSec, and we are actually asked to move away from MMSec, and then we move to KKit and something else on top of it, most likely something from Hugging Face. So we expect to have training ready data for those two things. So those are jobs. In the case of foundation model training, it's a Torch X run, which then submits to MCAT. That gets scheduled. And in the case of fine-tuning, we just submit the Kubernetes job. So that's the training part. Then we have the pre-processing part. And we actually have started the effort of having everything centralized. So we call every data transformation step, or also data download step, we call this an operator. And they are eventually transformed into KFP components automatically, by the way. I'll show you later how. And then we have the workflows. They are here. And at the moment we started the discussion. So let me maybe just show you one of the workflows. So this is a KFP DSL. You see here step 1, step 2, straightforward, blah, blah, blah. No, there's nothing I need to explain here. We have started some efforts in looking into CWL. Let me double check whether I can open that one. Workflows there. Actually, we just did it today, no? To see if we can use CWL. The reason behind that is because we have some, let's say, clients or partners which are not on OpenShift and KFP. They are on Slurm. So we either want to run a workflow directly on Slurm, or we want to use KFP, and that's the commercially preferred solution. We want to use KFP as, let's say, the driver or front plane, and we have specialized wrappers which wrap our KFP components and somehow send them over to Slurm. That is not yet decided, but we have had a look into CWL, whether we can use CWL as the single source of truth, and from CWL we compile then the KFP DSL. So that's for the workflow part. Another important thing is parallelization. So for parallelization, if you're lucky, you have a library which is running on top of Spark or Ray or Dask or something. But we realized that nearly every second workflow has at least one library which doesn't have. So an easy way to parallelize a non-parallel library is data partitioning, and we automated that. So we actually can wrap any KFP component into a so-called grid computing wrapper, and we then extend the interface. So we actually pass through the components interface, and we have additional parameters, which we then actually use to coordinate parallel execution. And the coordination is done via storage or cost buckets. So we actually create log files and processed files on each data partition to actually control what partition has already be worked on. And we have linear scalability for most of the cases. So we run stuff 100 times parallel now easily. And by the way, I told you we automatically create the KFP components. So from a notebook or Python file, we automatically create the container image. So that's the source to image thingy, which is still in my head. I need to talk to Red Hat, because Red Hat is strong in source to image. So we have at the moment, we have our own way of doing it, but I would love to work together on that. And it takes Python scripts or R scripts or notebooks, and it creates a container image. So you can pass the base image as a parameter or a Docker file template as a parameter. It automatically installs all the dependencies. It puts this code into it. It converts it first to a Python script. It pushes it to a registry. And at the same time, it creates that's something I have messed up. Sorry, I need to double check later. So you see it's automatically pushing this, then versioning it automatically and pushing it to the container registry, generating all the environment variable parameters, which we pass from the code, here. That's the interface of the component, We actually get whether it's optional or mandatory via the second parameter here. If we find any casts, so we support string, integer, float, and the Boolean at the moment. Sorry. And we grab this information and we create Kubernetes jobs, and we create KFP components. Oh, it's completely messed up. I need to double check the repository then. So you see here that's basically a KFP component YAML, and that's all auto-generated. And also the wrapping, so we automatically generate the wrapped components. And I told you about Slurm and everything, so that will be also automated. So you have the component, then you have the wrapped component, which you can run multiple instances of it in parallel automatically. You just need to add 3-4 more parameters to actually tell the component how you want to partition the data. And then what we also want to do is 2 other targets. One is Slurm, so that you have a KFP component, which then sends jobs to Slurm. And the third thing is to use MCAT as a scheduler and not the native Kubernetes Kubeflow scheduling system. And then, the workflows, we do straight KFP. So you see here, let's actually go to run, which I'm currently trying to fix something. And by the way, this is our staging environment. So we are using ODH. It's not working. I need to go to VPN. We are using ODH here. And I think it's an old version, because the new version, it seems, has stripped away the UI.
I think he froze. Did he freeze for everybody else?
Yeah.
I can see his screen. Romeo is still there? Oh, nope. He totally. Yeah, he totally dropped and lost connection.
Hey, can you hear me?
Yes, we can. I think he dropped out.
So that was the VPN. So sorry for that. So I need to re-share. Okay, so yeah, and then that's for example. Okay, see, then at the moment it's just here's the 20 instances of this KFP component, which is the same code, no, but the parameterization is no, sorry, not even that one. They are really the same code, same configuration. They just run in parallel. It's pure and it's pure grid computing. So it tries to grab a job which is equally is a partition, no? So each partition is a job, and it double checks if that partition is already locked, and if it's locked, it's grabbing the next one. And we also have a ramp up system that the workers randomly wait for something between 0 and 10 seconds. No, that we don't have 100 workers attacking the same partition at the same time initially. Yeah, and that's how it works, and we are relatively happy with it. The only thing which made us unhappy, I think that's where we met last time, is that this UI actually is not available for us anymore. Because what we do is, I showed you last time, no? What we do is we have these pipelines. So we have a lot of researchers, no? They are not that familiar with coding and DevOps and all that stuff. So what we can then basically do is we create a pipeline for them, and then they are really happy. No, they are more than happy to understand what all those parameters mean, so they don't need to code. No, and I mean, you know all this. No, and then we are actually actively using all that stuff. No, so we go into the pipeline and see why it failed or why it didn't fail, and we look at the config and double check all the parameters. No, this is basically how we work.
Okay. Yeah, so since you're using Kubeflow there to set up pipelines and everything, I'd be curious, any challenges, or just like within Kubeflow itself, how well does that support what you're trying to do and accomplish? Do you feel like there are any pain points or issues within?
Yeah, so I would say the execution and reliability is great, but the learning curve for a non-Kubernetes is far high. So that's why we came up with all those simplifications. No, this compiler system that the only thing you need to know is Python code. So creating a KFP component for a normal person is just too complex. They have to learn YAML and Kubernetes, and Docker and all that stuff. It's too much, no? That's one problem. So I think we solved that with that source to image thing, the C3 compiler. The other thing is debugging. So the logs are there, but it's like you either use the OpenShift console, or you use the CLI, or you use the KFP UI, which we don't have anymore in production. No? So we have only the two options. And so that's why we actually think about using Fluent to aggregate all the log files, and using something like Grafana and all that stuff. No, so the logging and let's say finding the errors is a bit hard. No, if a pipeline runs, everybody's happy, but if it's turning red, at the moment you come back, the logs are gone. No, if you directly use the UI. So that's the huge, the largest pain point at the moment. So we need to address that, but we have an idea. No, we have a prototype for. I don't know if you have a better idea. Just let me know. So that's the debugging stuff and development, because to really develop something, you need to create the components, you need to create the pipeline, you need to upload the pipeline and run it, and then you see the errors. So there is no. Maybe I just show you one thing which I really loved, and which is a bit problematic because maintenance is lacking. So let's actually. So one thing you should never underestimate is laziness of developers. No, if there are 5 clicks instead of 2 clicks to go to somewhere, it's painful. No, and they start to not use stuff and not like stuff. So I guess you know what I'm doing, but if not, let me know. So this experience was actually the reason why I decided I want to manage the Lyra team 2.5 years ago. So I haven't configured Kubeflow here. But here, the key thing is if something fails here, I mean, it would be even better. That was something I requested from the team, but they destroyed the team before they implemented it, is to grab the status from OpenShift and highlight those things in colors. No, if it's running, if it's failing, or if it's succeeding, like turn it into green. Okay. And then what you can do is, I would have loved to see then option to see the logs directly from here. And also what you have is you double click and it points you to the arrow. No, the position where the arrow is highlighted in the code. That's how people like to develop and debug stuff on Kubeflow, I think. But yeah, we don't have the resources anymore to like finish my dream. But yeah.
Okay.
And that's a problem, no? Because now things happen, and the guy who ran this workflow, he has no easy means. No, let me go back to the Kubeflow run. So let's assume that this is a run. No, let's take this one. Doesn't matter. And this was successful. Let's assume this was red. Now the logs are gone, but this guy has not an easy time to even find out where to find the code. That's why we started now with CI/CD. So what we do is we version everything. When you check in the code, we create the component and the container and everything in the YAML. So we tag and automatically increment the version by 1. So at the last level, no, it's then 1.5.x, and that x we increment by 1 each time you commit to the main branch. And then the version of the component you can find out here somewhere. You find it out. I need to double check where, but you find out the version of the component, and then you can go to GitHub and go to the tag, and then you see the version which failed. No, that's really important. And we do the same for the workflows. So we have then for each workflow we have pipeline. Sorry. We have different naming internally. For each pipeline, we also have one version. When if somebody changes something, there's a new version. And we also, in the near future, so we have another rule for data governance. So we have the raw data in costs. So we are migrating all data from HBase and from external sources to Cloud Object Store. And we have data catalog. And we want, and for registering data to the catalog, there is a specific KFP component, which is in the pipeline. And we want to screen all the workflows. So we have a central repository for components. We have a central repository for workflows or pipelines. And in the moment someone is writing to costs, so we can find out, no, we can screen the pipeline, and not writing to our metadata catalog, this will trigger a notification, and we can look. So that way we try to prevent that people are writing data to costs and not updating or inserting stuff into the metadata.
Okay.
Yeah. Okay. So.
Yeah. Thanks. Yes, that does help. I actually want to take a step back for a second here. I know you've said we a lot here as you've talked about this. Yeah. I would be curious, like, what exactly does the structure of your team really look like, and like who is doing what within this process? Okay.
So I'm the architect of this workflow and operator framework. We call this workflow and operator framework.
Okay.
So this is all basically based on the idea when I still was managing the LiDAR team. That was my side project for the last 3 years. And I've driven it with some help from others to a stage where we donated this to the Linux Foundation, and now we got an IEEE award for it. And I think it's the number 3 project in IBM, open source project, number of stars and forks and so on. And now I have intern, which is super fast and smart. He's doing most of the work in the framework at the moment. So at the moment he's concentrating on the compiler. So and on the CI/CD pipeline. That's me in a sense. So that's only 2 people, mostly on that one. And then we have around 25-ish researchers.
Okay.
And they actually migrate stuff, or if they create new stuff, they're using this framework. So they come from so they are like climate physicists, and one guy is particle physicist. So and those type of people. So they are good in coding, super scared of OpenShift and Kubernetes.
Okay.
And yeah, we actually open the door for them. No? So we tell them, just port your code simply. No, you just need to follow 3-4 rules in the code. No, you have to have a title and a description and the interface in one place, the inputs and outputs, and check it into somewhere, and we do the rest. Then you already have the components. No, and then so that's an easy part, because they have just huge scripts. No, they can easily strip it down to little pieces and check it in. That's one part they need to do. The other part is writing the KFP DSL. And that's okay. No, I mean, that's relatively simple code. And the third part is they create the YAML and upload it at the moment manually to KFP using the UI and staging. And yeah, and I have looked into the OpenShift UI for Kubeflow, and it doesn't have all the functionalities we need. So I cannot give it to those guys and say, here's the UI and please upload. So we are a little stuck. We don't know what to do at the moment. I'm still waiting for feedback. If you might be able to eventually, in addition, provide the upstream Kubeflow UI. Now, if you create a tenant or instance or project which has Kubeflow, that you also give us the UI. Otherwise, we either need to wait for the functionality to come into your user interface, or we need to code something ourselves, so that we then call the KFP API. And like, people need to somehow upload the workflows, so we can also have a little. We tried that in the code where the pipeline is created with a DSL. We have another block which actually uploads the pipeline and triggers the pipeline via code.
Okay.
But people really love the UI experience. No, so once this pipeline is there, you can send it to anybody. We have a super skilled climate physicist. He has no clue about programming, but he just works with other clients, and he needs to train a model, and he can do it with in the staging environment. No, we have sent him the URL to Kubeflow. He can actually go to the pipeline, and he says create run and has his parameters. So it's a pipeline which downloads data, satellite data from somewhere, does some pre-processing and puts it to somewhere. It's a whole pipeline. He needs to provide 5 parameters. He runs it. It takes 2 days. Then the data is there, and then he can trigger another training job, also via UI, by the way, in the meanwhile. And so without coding skills, he can grab data from somewhere, train a model, and expose the model as an endpoint and send this endpoint to client without being a computer scientist. No, that's how he actually got with the whole system.
Okay. That is helpful. Do you have data scientists working on your team, or is it the researchers that are working with the data usually?
Yeah, actually, those are researchers which became data scientists. We don't have. So I'm maybe a data scientist. So in my previous role, I had the title data scientist. Now I'm a software engineer, data engineer. But yeah, we are basically telling those guys to become data scientists. And I mean, they become the ordinary citizen data scientists, where they write a lot of spaghetti code and notebooks and put these files on clusters and servers and write files and read files here and there. And if they're on vacation, nobody has no clue what's going on.
Okay.
And actually, so the process before I started this effort was like each let's say workflow step was a person with an account to some server. So in 3 different time zones. So we had to tell the Japanese research team download satellite data. Once that was there, a couple of days, we had to tell the Brazilian team transform the data, and another team in Zurich, please train the model. And it was so much overhead from the, let's say, coordination side and time zone problem. That was one thing. In the code, it was a single script. They couldn't run in parallel. So they had one download, and one transformation script, which took 30 days. And with that grid operator, we could bring it down to less than 1 day. So we just could take his code, wrap it in the grid operator automatically, and then it was done in less than 1 day. So, and since this is no part of a pipeline, now it's versioned, the code is versioned, the pipelines are versioned. The data will be versioned soon. We need to find a way how to read the version of the KFP pipeline. And by registering the data to our metadata store, we put the version of the pipeline who created the data, metadata entry into there. Then we can track everything down now. So we actually now where the data came from, which created the target data, and what code and what pipeline and whatever was involved now. And I think once that is done in a couple of weeks or month, I don't know, then I think we are pretty much done with this part of the work.
Okay. All right. And I know you mentioned, go ahead, Kyle. I'll just pause before I shift this somewhere.
Sorry, I'm interrupt, but I was just curious, you mentioned Git and using CI/CD. Are your users, I don't know, we're not calling them data scientists, but are they using Git themselves, or is that another process that you've automated?
We force them to use Git. And we help them sometimes. So today I told someone how to check on which branch he is and to commit and merge from command line. So they still kind of work in their SSH environment, but to get this scripts working, no? But then they are supposed to use Git. But the only thing they need to do is to actually push to a branch. So we do help them with creating the pull request and merging it in. And also the CI/CD pipeline is something we maintain and double check that everything works. But most of those, they can actually call the compiler. So it's a pip install claim -c3 since 3 days. We have it on PyPy. And you say then create component and the file. And then they check if it works or if it raises an error. And if it works, then they're allowed to check in. And the CI/CD pipeline will do the same and create a container image and KFP, YAML, and I don't know what for us. Yeah.
Awesome. Thanks. And then I had another question too, which is maybe slightly related, maybe not. I don't know. But you said that there's functionality missing from what we have versus the Kubeflow. I know that there's definitely stuff that we don't have in there. You mentioned logs. Was there more than just the logs, and that the logs disappear over time, or was that?
Yeah, I mean the logs. That's not kind of your fault, not the logs. That's the problem of I think how you configure Kubernetes, how long those are kept, no? And since the KFP component steps are pods and then the logs are gone, no? That's not the problem. One problem. That's one thing. If you click on KFP component execution in your UI, you cannot access the logs. Yeah, that's one thing. So what we need to do at the moment is to grab the name of the pod and then go to OpenShift console and then grab the logs from there. I think in the last, I mean, you should still have the recording. I think there were 2-3 main, let's say, blockers. One other thing is you have a run, and in the KFP upstream UI, you can say clone run. Then a new UI pops up and all the parameters are still there. You have seen we have around 30 parameters. No, now imagine if those are empty, then you have to like copy paste 30 parameters every time you clone a run. That's a minor thing, but it's super tedious, no? And there was a third thing I don't remember, but I can find out if you're interested. We can do another comparing session between the two.
Perfect. Thanks so much.
Okay, Romy, so I know you mentioned you've done some like model training as a team, also like building containers and things like that. This might be a dumb question here. Keep in mind, I'm a researcher, so maybe I didn't just totally follow everything. Do you guys also deploy the models as well?
Yes, so we use, at the moment, we use handmade containers.
Okay.
And I did it out, I think it's even Flask, and then some way of serving, but we are really, really pushed hard, and we also want to use KKit and model mesh. No, so those are the two things we are heading for. But at the moment, for time reasons, we are not using any of those.
Okay. So are you the one who actually is involved with the deploying of the models, or is it the researchers or data scientists here that are kind of involved with that? Like, what does that process sort of look like when it comes to that?
Okay, so we have actually, so I'm a software engineer role in research, and we have a couple of more software engineers, and those folks actually have created a tool which we call the Watson X Studio Geospatial. I mean, you might have heard about Watson X and Watson X Studio. So the idea is it's a UI where you actually can create inference services or fine-tuning runs. And the whole model lifecycle management is then handled by the tool. That's the plan. At the moment, we can just name them. So we can create a fine-tuning run. The result is a model, and we can give that model a name. And we can click a button, and it will be made available as an endpoint for someone to consume. And if you want to do versioning, you just have to have it in the name of the model now. Colon V1, 2, 3, 4, 5. In the moment we switch to model mesh and Cake-It, we can then use all the goodness what that provides, the red-green deployment and lazy loading and versioning and virtual versions, and I don't know what it can do. So that's the plan, but we didn't implement it yet.
Okay. Yeah.
And the researchers and our clients, they are not supposed to actually touch the code. The only thing when they touch code, they might get some sort of an editor window, Jupyter Notebook, something where they can provide custom code for PyTorch model architecture configuration. For example, in those foundation models for specific tasks, sometimes you need to change the encoder decoder head. That code you can like paste in and then start a model, but that's for the advanced users. The other ones, they actually will get a drop down of all the foundation models we support. So those are the ones we create, and those are the other ones which we get in open source. They choose the hyperparameters of the model, and also we want to provide hyperparameter tuning in the near future, that you can select the parameters, parameter ranges, and we are discussing whether we want to use Kubeflow Cadip for this one or a RayTune. I'm trying to find out. So in my opinion, we should use Cadip. But there's another fraction of people which are very fond of Ray. So it might be RayTune, but it both runs on Kubernetes. So we are fine.
Okay. Yeah. And then focusing on the model training aspect of it, like what are the biggest challenges for you guys as a team trying to accomplish some of those tasks that you have with model training?
It's still, let's say, the coordination in the team. If you at the downstream stage find out something needs to be changed, you need to find out which pipeline step actually caused this change. So that's still something we didn't solve, no, because you have the data. It has a specific shape and a specific problem, and you need to look at the pipeline, which step might be responsible for that problem, and then you need to find out where you can change it or who can help you to change it. Then you need to rerun the pipeline. Also, we start to implement laziness in the pipeline. For example, downloading. We also already have lazy downloading. That means if it's already downloaded, it won't download again. For pre-processing steps, we didn't do it yet, unless you keep, if you use the grid operator, for each partition, we have this log and processed files. Now, if you keep those, then we know it's, but if you really need to pre-process, again, you need to delete those files that it gets all pre-processed. That's one thing. Then we have a lot of performance issues. So we were training in the cloud with COS, and then we moved this to local training on a local OpenShift cluster, and we had a 10x speed up. We found out the bottleneck was the COS. We are now using IBM storage system and GPFS, which we mount as NFS to the pods, and we directly read and write from there. And then we found out that we even accidentally only used half of the number of GPUs. So we might even get a 20x. So we'll see. What else do we have as challenges? Yeah, a lot of trial and error now in the models. No, sometimes the performance of the models is not as it should be. And then we really need the experts to find out. There are really a lot of corner cases which you cannot generalize. No? You need an expert looking at even debugging models, looking at results from intermediate layers and finding out that some of the source data had a problem. So that's something we cannot kind of automate. No? We still need some experts who understand what actually the deep learning model is doing.
Okay. Yeah, and you mentioned like the model performance and all of that. So how do you guys try to monitor that model performance? Like, what does that look like? Is that within the team, or is that with somebody else that you're working with? You mentioned experts there. So I'd just be curious to know that aspect of it.
Okay. Now we define some metrics. We define metrics and we test against the metrics, and I mean we are pretty harsh. I mean that's the only thing people are working towards, no, to get a better performance, and they are really aware of the performance and if that drops. So each model run, actually the last thing you see at the model run is the performance given the metric we define. No? So we are very much aware of the metrics and the improvements. What we not
Really quickly, are you defining those metrics, or is that somebody else that's defining what those metrics are?
No, we define, so not me, but the researchers who come up with the model, they are pretty clear on what the metric should be.
Okay. Yeah.
What else? The hyperparameter tuning is one important thing. Because it's a lot of trial and error, and I really urgently need to provide the team a way of doing hyperparameter tuning. So since KTIP is not part of the Red Hat offering, I really need to see what I do, if I install it myself or if I go to Raytune, but I'm still waiting for feedback. I still could use HyperOpt, but the people are really asking for that, because I give you one example. We have a model, a regression model, which was performing poorly, and they just came up with the idea of discretizing the target variable and just creating a couple of categories. And for example, the number of categories is a hyperparameter, and they wanted just to try a couple of this and a combination of some other things. So it was, I would say, around 50 experiments. And what they did is run one by one and having a box note and writing the results. No? And it's like paining in my heart now to see that, because I know there's a one-click tool which is able to do that. So that's one of the next things I really need to do.
Okay. Yeah, I had hey, this is Dash. This is really good. I'm learning a lot from you. When you say that they had 50 one-time jobs, did they have to, like, how did they even track which changes they were making? Did just in a spreadsheet or something? And
yeah, we have this tool called Box Note. We call it the Box Note. So there's a table in the, it's a spreadsheet basically.
Okay, gotcha. So they had to go back and look, okay, how did that one do? What about
exactly
number 8, like number 23? Like,
yeah. and that's basically manual grid search what they are doing, no? And as you might know, in optimization, we have, for example, Bayesian optimization, where the algorithm tries to estimate a Bayesian distribution on the optimal selection of parameters that you actually don't explore regions which anyway don't make sense. So they are not doing, they are doing that maybe by gut feeling, no, but not by actually creating a model. So Bayesian, in KTIP, you have you have hyperband and grid search and Monte Carlo, and you have Bayesian optimization. And I mean, if you're interested, I have a series of YouTube videos which I created like 2 years ago about this. So I can share that with you. It's actually showing to you how to actually use KTIP. It's pretty cool. Cool. Yeah, but it doesn't matter. No, KTIP I like, especially it's just the container. And I think 2 years ago, I created a issue on the KTIP GitHub why you can't optimize over KFP pipelines. No? You can optimize over containers, but actually, for example, it's a very specific example, but the way how we remove clouds from satellite image affects the model performance. And that is a parameter we have in some of the pre-processing KFP components. So if we want to optimize over that, we need to manually change this option and create different data sets and then run the models on different data sets. But if we could just use the KFP pipeline with the hyperparameter tuner, then that parameter can become one of the hyperparameters, and it's just then fully automated. No, so yeah, that's the luxury I have the honor to work on, kind of.
Okay. And since you mentioned automation there, and you may have mentioned this in some of the previous responses you've given, like what role does automation actually play with the model for your team?
Yeah, we get like a tremendous speed up, because the bottlenecks was communication. Most of the bottleneck was communication across time zones.
Okay.
So each let's say KFP step had a 1 day delay, because there was a time zone problem. So you send this to the Japanese team, and they do it the next morning. And when you read their response, they're already kind of going home. Or people are just working like until midnight everywhere, and then you get 2 iterations per day. That's one thing. I think that's the biggest improvement we actually have now with those workflows we already ported to Kubeflow. And the other thing is some of the stuff just takes ages, and with the grid wrapper, we just can push it down to what we like. Now we have a 32-node Red Hat OpenShift cluster, which we use for pre-processing, and we can run, I think, at least 128 pods in parallel for in Kubeflow. So that's at least 100x speed up, and that's bring down from a month or more to less than 1 day. So that's really cool.
Got it.
And then now the automation is basically from code to the workflow or to the pipeline. No, that's also kind of automated. It's nearly finished. I would say 80% is already done. We did a lot of progress in the last couple of weeks. So we are using Travis at IBM, and then we basically do everything automatically now.
Okay.
And we can track it down. Now that's another important thing, that we now know which data set has been created by which workflow, which KFP component, which version of the code. For example, it's really important if a model doesn't perform, you train it on data. No, you train it on data and it doesn't perform. You need to debug this model, and you need to track down, in this particular case, which cloud removal algorithm has been used for that model, and if that caused a problem. And if a better performing model, what's the difference? Is it only the cloud removal algorithm and this data has only been changed, or something else? No. If you don't do that, or if you do it manually with Excel sheets, you'll be messing up things. No, you at the end you don't know why your model was performing better than the other. No, so we really need to make sure we always, even if it's tedious and we need to take a look at many branches and tags and blah blah blah, we have the information there to do it. No, that's important.
Okay. Yeah. All right. This has been great feedback, Romeo. So I appreciate you kind of walking through and answering some of these questions. I know you've talked a lot about the different tools that you've used. I do want to check for a second. Are there any tools or systems that your team uses to support the work that you have that you haven't mentioned in describing some of this stuff today?
I mean, some folks are really keen to use PyCharm. So PyCharm, VS Code, notebooks are like the tools we are using.
Okay.
We are using a lot of IBM Spectrum LSF, which is a proprietary version of Slurm, basically. But it's because we have compute there. Now people are doing this for a decade now. So the way how people still work is we have a storage system, which is basically a GPFS storage system, which has a couple of petabyte, and that's mounted to worker nodes. And then people just create Python virtual environments or Conda environments, and then they submit jobs using the LSF job queue, which is similar to Slurm. That's where people are coming from, no? And yeah, in the moment we actually tell them, see, it's a OC apply -f blah blah blah, and then you can go home, and the next day you come. They really like it, no? But you have to actually help them. So it's really important to have these automation tools, but I talked about those already.
Yeah.
Let me double check if there's some other tools. I think the most tool they use is a plugin in macOS where you can browse Cloud Object Store, because all they do now looking at data. which is not available on Fedora, which is a pity. Any other tool? Let me see. I think that's basically it. Obviously, all we have in so that the researchers, they are really fluent in coding. No, they are not, let's say, perfect software engineers from like creating reusable good code, but they have tremendous knowledge about libraries and what's happening inside the libraries and math and that stuff. So that wealth of tools we are using, what the data scientist actually is using. And we need to support it. No, we need to support all the tools. For example, GDAL. GDAL is a library which they use a lot for their geospatial stuff, and that actually requires some C libraries. And that basically was the reason that the simple pip install didn't work out. So that's why we, for example, added the option to add a custom base image for the compiler. Which then had GDAL installed. That's a simple example, but that way we learn. No? And I think my task is to find Red Hatter to talk to him about this S2I integration, because we do S2I and maybe we can join efforts there.
Okay. Yeah. All right. So I think I'm getting closer to the end of my questions here. I want to pause for the group, everybody on the call here, and ask, anybody have any specific questions for Romeo that we haven't had a chance to dive into yet?
I had one. I think it's probably because I missed it, but you had said earlier that like you were deploying to cloud, now you deploy on-prem, and you get the maybe a 20x if you figured out the GPU thing. So are you saying that like any model that you train is ends up getting served on that machine, or do you have like an external CI/CD system that deploys to other clusters and so on?
Okay, so that particular case where we got this 10x speed up, that's foundation model training. So that's different from the rest because that uses a lot of data. And then the bottleneck plays out. So we cannot actually copy all the data to the OpenShift local storage unless we have an OpenShift system which has super fast. So we have, I think, 400 gigabit connection to the storage. That's fine. And on cost, we had around, I would say 10 to 20. That's where that 10x came from. No? So that's specific to the foundation model. If you have like terabyte range data, that doesn't play too much of a role. So the foundation model is trained on a, let's say, larger OpenShift cluster. And what we then give to clients and end users, which is then actually ending up in the Watson X platform, Watson X Studio for Geospatial is the product name, that ends up on a smaller system, and also the fine-tuning. So we are using this foundation model. So we copy the model to that other cluster, and we offer it for others to fine-tune that foundation model with their data. And all that stuff is happening on a different system.
Okay. Do you use, what do you use for CI/CD?
We use internally, we use Travis, and we have I told you, this Claim project is open source with the Linux Foundation, and that is using GitHub Actions.
Okay, gotcha. And I think you said the intern's working on that, the smart intern.
Yeah, the smart intern is basically working on this S2I stuff at the moment. Yeah.
Oh,
so,
yeah, okay.
Yeah,
and
he
that
became,
that would be like part of your CI job, the front end of the CI job, eventually.
Yeah. So he actually became the #1 contributor to that open source repository yesterday when I accepted his pull request. And now actually this S2I compiler is super smart. It can do a lot of things. And I think in this moment, he's currently implementing it on Travis. So it's already implemented in GitHub Actions. So if you go to github.com/claim-framework, and you upload anything into the component library via pull request, then once we accept the pull request, automatically this GitHub action is already compiling this to an image and the KFP component and registering it and everything. And he's now doing the same internally for the CI/CD. So the idea is we have the compiler, this is open source. We have an open source library with open source components like reading data from a database, I don't know what. And then we have our proprietary components, and those are in our internal repository. And in the internal one, we use Travis CI.
Okay.
So the code lifecycle management is GitHub Actions and Travis CI, and the data lifecycle management is Kubeflow Tecton.
All right. Thank you.
Welcome.
All right. I think that might have been our last question. Anybody else had any others to ask Romeo? Seeing no, so.
I might have one
No.
more.
Dash, if you have one more, we got 4 minutes if we want
All
to
good,
go.
all good.
Yeah.
So once you serve models somewhere and there's the endpoints are available, how, like, downstream, are there applications that are, like, using those as an endpoint or dependency? And if so, how are the changes communicated to them, and how do they know, how the API has changed and what they need to do to incorporate that change?
I mean, the API shouldn't change unless we did something wrong in actually coming up with the API. The model obviously will change. So at the moment, we cover it via model name. We have a version in the model name. There's no automatic way of informing clients. So actually, our clients are the ones who create the models and also consume the models. So they need to have some internal process in making them aware that someone created a new model for somebody. So that's their problem, basically. And then we have an internal client, which is our enterprise environment intelligence suite. It's a product in IBM. So it's our internal client. And what they do, they use the whole system just to generate layers in their data lake. So they have the raw satellite data, and then we have models, for example, to, I don't know, segment stuff, to see where the rivers and the houses are, or to estimate above ground biomass, or to detect, I don't know, floods. I don't know what, no, you name it. And they are creating, using our model, which we serve on an endpoint, they are creating data layers in a batch process and store back the data layer to their data lake, and then make that layer available in their UI. You have, like in Google Maps, you have the layer where you see the planet, and then you can switch on and off the different layers as an overlay. And that's how they actually work it. So they don't make synchronous calls to our system when one of their clients is using the system. They are just showing pre-processed data. There are some ideas of how to do that lazy. If a client requests a huge area which they don't have, then a batch job actually will create that layer and inform the client once it's there. But that's stuff they take care about. So yeah, that's, I think, does it answer your question?
Yeah, it does. Thank you.
Okay, welcome.
All right, and I think we are really close to time here. So I just want to, again, thank you so much, Romeo, for taking the time to chat with us. This was really great to get to hear your feedback and chat a little bit with you. So thank you so much. Do you have any questions for us before we jump off for today?
I mean, I need to look into what you're doing, but I think we can't do that in 1 minute. So maybe I just see how far I get myself to find it out. Then maybe I just
feel free to send us any questions or anything if you're curious. We're happy to.
I mean, I'm the consumer of this, in the near future, so I need to see what you're doing. Good.
Well, that sounds great. Well, thank you so much. Hope you enjoy the rest of your day. And
you too.
Take care.
Thank you.
Thanks so much,
bye.
Romeo.
Bye. Thank you.
Thank you. Bye.
Thanks.